Hi, this is Mrs. Short, and these are the review problems you had to do for your test or next class. Please watch and pay attention and also do some studying on your own. Alright, so this first problem here. Anytime you're given a graph and some equations, go ahead and graph on your calculator. Make sure that if you graph these, you were to put parentheses around the top and the bottom so that you would get the proper graph. But looking at this graph, I can kind of tell that there's probably an asymptote right here, and that seems to be at -5. So I know that any time -5 is in the denominator, then I get a 0 in the denominator. So when I look here on letter A, if you put a -5 in for x, that's going to get you 0. So that's a possibility. On letter B, if you put a -5 in for x, you're not going to get a 0. So that's not a possibility for this graph. So the other other possibility is letter C, and letter D is not a possibility. So in our case here, we're only going with A and C. Now, looking further. Again, you can graph this on your calculator, you get a direct match with one of these. But if you look at letter C, my horizontal asymptote, the x's are equal to each other, so I use 3/1. So my horizontal asymptote here is 3. In letter A, the x on the bottom, there's no x on top. So that means my horizontal asymptote is 0, because the top is smaller than the bottom with respect to the degree. So that means that I would choose letter C. And it does look like if I go to about 3, if I draw an asymptote there, that this graph pretty much follows that. Because 0 is too low, it's going to cut through the graph right there. All right, let's see. Next one. Let's see. All right, for number 2. The graph of this, they're talking about x-intercepts and y-intercepts. All right, so I can tell here that basically I would go and look at my graph. When I look at this problem, I have 2 and x plus 5 if I factor. At the bottom, I have x plus 3 and x minus 3. I did that because nothing cancels. I wanted to check and make sure. So x-intercepts and y-intercepts. Well, for a y-intercept, I want x to be 0. So let's pretend x is 0. So x being 0 in this problem would make the x's go away, and I'd have -10/9. Well, -10/9. So there is one y-intercept. So I know there is one y-intercept. I just found it. So these answers that say no y-intercept, I will get rid of. And for an x-intercept, I have to pretend y is equal to 0. So basically, I'm trying to pretend that this fraction here is equal to 0. Well, we all know that a fraction equals 0 when the numerator equals 0. So when does 2x plus 10 equal 0? Let's see, 2x equals -10, x equals -5. So -5, 0 is the x-intercept. So it seems like this has one of each. So I would choose letter B. Now again, you could look at the graph and you could probably see the intercepts and count how many there are. All right, number 3. Number 3, as x approaches -infinity. Well, when we're talking about the end behavior of a rational function, that's really just talking about the horizontal asymptote, or HA. So in this case, I would go here. X squared over x squared, these are equal, so I use my leading coefficients, 4/2. So that's 2. So once you know your horizontal asymptote, you know your end behavior of a rational function. So that would be letter C. Or again, look at the graph. Always just graph it. That would be the best thing. All right, number 4, asking you about horizontal and vertical asymptotes. Well, looking here at the denominator, x can't be 4, so x equals 4 is my vertical asymptote. It's like an SOL practice where you slide that over. Horizontal asymptote, I will look at the leading coefficients because I have x's that are the same. So 5/1, so that'd be y equals 5, my horizontal. All right, let's see. Next one. All right, the graph of a parent function is shown. So this graph looks like it has an asymptote. If you graph all these 4 items down here separately, what's going to happen is that this graph, some variation of, let's see, that graph will look like, so here and here. So basically both items are facing down. If you graph this problem over here, you will get kind of something similar. You will get both items facing down. So they're not split. So what you are going to get if you graph these two is you're going to get something similar to what you see above. For the negative 3 over x, you're going to get a picture that would be, let's see, down here and up here. So that's pretty much similar. For the negative 3 over x plus 1, you're going to get the same kind of graph but move one to the left. So you're going to get kind of like this and like that. But, like I said, just graph every single one. Whichever one looks similar to this original problem here are the ones in the same family. So the two that I circled are your answers. All right, simplify the complex fraction. As I do this, I'm going to factor. So the top fraction stays the same. 9x squared minus 1 factors into 3x plus 1 and 3x minus 1. That is a difference of squares. In the denominator, you have 5x and x. And, you know, I mean, you can put this in your calculator, but basically I see a 2 and a 1 should go here. That way I'm going to get 10x and 1x, all positive, to make my 11x in the bottom. All right, so this bottom fraction here, remember that flips up. So on top it's going to be 10x plus 4. Well, I can take a 2 out of that. Take a 2 out to leave me 5x plus 2. All right, and in the denominator, I have 27x to the third plus 1. Well, that's cubes. So I have a little part and a big part. Let's see. So the front would be a 3x and a 1 because that's what makes 27 and 1. And then over here I do square, multiply, square. So if I square 3x, I get 9x squared. Multiply 3x and 1 together, I get 3x. Square the 1, I get 1. And then I use my SOAP. So I do same sign, opposite sign, always positive. Now, the only thing that I see that cancels here is the 3x plus 1. Pretty sure I meant more to cancel, but I must have messed up on my arithmetic here, so, oh well, got what we got. 2 and 5x plus 2 on top, also 3x minus 1. In the denominator, 5x plus 1, x plus 2, and 9x squared minus 3x plus 1. All about factoring. All right, number 7. 7 says to graph this. Well, looking at it right now, I can see the horizontal asymptote. I use my pieces right here. But why don't we go ahead and factor this first so we can see if anything cancels. So I'm going to do that down below. So the top, I can take a 2 out. So x squared minus 5x plus 6. All right, my denominator doesn't factor that way yet. All right, so keep factoring. I got a 2. This will be an x minus 3 and an x minus 2. The denominator, let's see, I'll get x plus 3. X plus 3. So what happens here? Cancel that. All right, x plus 3 and x minus 2. All right, so these x minus 2's are going to cancel, but before I do that, I'm going to name my domain. My domain is all real numbers where x cannot be negative 3 or 2, because that's what would be in the denominator, what would go bad for me. So, see these x minus 2's cancel. So that means that there's going to be a hole at 2, which leaves me a vertical asymptote at negative 3. These two items are always going to either be both vertical asymptotes or they're going to split up. One's an asymptote, one's a hole type of thing. All right, my horizontal asymptote. I can use the original problem or I can use my fixed version. In either case, the x value on top and the degree on the bottom are the same. X and x, or up here it's x squared and x squared. So either way, there's a 2 in front of them. So my horizontal asymptote would be 2 over 1 because I would use my leading coefficients. So y equals 2. All right, at this point, you are ready to go to your calculator and graph it up. So you got your vertical asymptote at negative 3. Get that on there. You have your horizontal asymptote at y equals 2. Put that on there. And basically for the rest of it, we're just looking for some kind of, you know, like a general graph after that. So let's see. All right, so I had to grab my calculator and to graph this thing. So for my graph, I'm basically going to have a curve up here, which is interested in it being perfect. And over on the right side, it's going to be down below. It kind of comes up here and cuts over. It's down. Okay, but you know there was a hole at x equals 2. So over here on our graph, when x is 2, I was going to be about right here. So I'm going to put a hole right there, and that's how you would properly graph this. All right, now the next few examples, there's about 5 or 6 of them, you need to take notes on. That's going to be part of your homework grade, that you have notes taken on these examples. So here we go. You don't necessarily have to write the whole problem down, but you know, any work that I show, you should write that down and maybe write the original question down. All right, so if you need to pause the video to copy down the problem, then do that. Otherwise, I'm just going to go ahead. So, on top of this, 5c squared over d to the third. On the bottom, though, of the top fraction, because this is a complex fraction, if you notice, 10 is a common factor here. So if I take out a 10, that would leave me with c squared plus 2cd plus d squared. All right, so I know that 10 has to be out front, and then the rest of it's going to factor into 2 pieces. Well, to get c squared, I would need a c and a c in front. To get d squared in the back, I would need a d and a d. So you notice that you have cd and another cd. That makes 2 cd's. You just put addition signs in between. So that seemed kind of bad, but it's not too bad. Now, the complex fraction means that we had to flip up the bottom. So times, the top of this is going to be the 2c plus 2d part. Well, I can take a 2 out and get c plus d. The denominator is already factored for me, 3cd, and then I have c minus d. All right, so now we're ready to cancel. C plus d's go away. Let's see, my 5 and my 10 over here make a 1 and a 2. But now that that's a 2, I can cancel this 2 with the other 2. And so let me write what I have so far. In the numerator, I have c squared d to the third. In the denominator, I have, let's see, I have, I need more space. So let's see, c squared d to the third. Denominator, I have a 3cd with a c minus d, and also a c plus d. All right, so it looks like I can take care of this cd with some of these. So if I cancel one of them each from the numerator, I'm going to have 1 c and 2 d's left. The bottom has a 3, c minus d, and a c plus d. All right, let's look over our answers. So notice I didn't look at the answers, so I was totally done. So it looks like a match is with the letter B. Okay. All right, second one here. So pause the video a minute. Take a minute to write that down. So this here is a problem where I have to do a common denominator. So my common denominator is going to be x plus 1 and x minus 1, just those 2 items. So it looks like the first fraction, the 3, deserves to get an x minus 1. Plus x deserves to get an x plus 1. So each time I'm looking what they had versus what I picked for my new denominator. Now the next part, the 4 already has everything in the bottom, so it just stays minus 4. So my denominator is going to stay x plus 1 and x minus 1. In the numerator, I'm going to multiply that out. 3x minus 3 plus x squared plus x minus 4. So let's clean it up. We'll get x squared plus 4x minus 7. And x plus 1 and x minus 1. All right, so I think I noticed a match here with letter D. Okay, take a minute, write down this next equation. We're solving for n. So, since this is multiple choice, you do have the option of just trying each of these numbers in for n. This looks simple enough to plug 5 and negative 5 in here. All right, but the way I've taught you to do it algebraically is we're going to multiply through by the common denominator. Well, the only thing I have to get rid of is n, so that's what I'm going to multiply through by. So, let's see. I would get here times here would be n squared. I'm going to multiply these two. The n's would go away, so I get plus 25 equals, multiply 10 times n, get 10n. Alright, so I have n squared here. It's not going away. So I'm going to have to pop that 10n right between here. N squared minus 10n plus 25 is what my problem becomes. It's quadratic, so I can tell I'm going to have to factor. Get n minus 5, n minus 5. So basically both answers are the same. N equals 5. Alright, so I do notice that with letter B. Also, you have to think to yourself, are you allowed to put a 5 here? And that would be perfectly fine. It doesn't make a 0 in the denominator. Alright, next one. So this is again the same kind of problem where I have to multiply by what I notice is the common denominator. Well, I definitely need an A and a 5. So I'm going to put a 5A there, and I'm also going to put an A plus 9. Those three things are in the denominators. So I imagine multiplying this by the first fraction. So the A plus 9s would cancel. So I'd have 4 times 5A left to multiply. Plus, in the next part, my A's would cancel when I'm doing this item. So I'd be left with a 2 times a 5 times an A plus 9 equals. Now in the last part, I frequently use this to cancel. My 5A's would go away. I don't like to cancel it earlier because I'm still using it. But now I can see I only have 15 and A plus 9. Alright, so I don't see any squares here. This is going to be pretty easy to solve. 20A plus, this would be a 10 here. So that would be 10A plus 90 equals 15A plus, let me see, 135. Alright, so that 30A plus 90 equals 15A plus 135. So if I subtract 15A from both sides, subtract that from the 30, I'll get 15A. And subtract the 90 from the 135, I'll get 45. So it looks like A will be 9. Now, I have to make sure if A is not 9, I'm sorry. A is 3. My mistake. So, I have to go and make sure does 3 work. Like, is 3 okay for the putting in for A right here? And that would be fine, as long as it's not negative 9. Is 3 okay to put here and here? That's fine, it's not 0. So A equals 3. That's my choice. Again, you could also just plug 3 in everywhere and make sure it works. You could do that with each answer. Alright, these two functions are graphed, and the question is saying to me, use the graph to solve this equation. So basically, they're giving me the graph of each one. X plus 10 over 2 is x plus 10 over 2. X minus 6 over x is x minus 6 over x. So they're asking me where these two functions intersect. Nothing is intersecting this area here, so I have to look there. So basically, I'm just looking over on the other side. We have a line and a curve. Looks like they're intersecting here and there. So I'd say at about negative 2 is the first intersection. Something about negative 6, because that's what x is when they are intersecting. So negative 2 and negative 6, or something close to that. So the answers. There we go, negative 2 and negative 6, letter D. Alright, so we're almost done here. A couple more. So take a minute, write that down. Now when I have a fraction equal to a fraction in a problem, I will just cross multiply. It doesn't matter which way comes first. I'm going to do x times x plus 2 on the left side. On the other side, 2 times 16 minus x. So on the left, I'll get x squared plus 2x. On the right, I'll get 32 minus 2x. Now, I notice I have an x squared here, and I don't see any more, so they're not going to cancel out. This means I want to bring everything over to the one side. So I'm going to add 2x here, add 2x there. I have x squared plus 4x. Also, this 32 needs to come over, so that's going to become a negative 32. So this means I'm going to have to factor. Oh, this one will be pretty easy. X and 8 and x and 4. 8 times 4 is 32. I do positive 8 minus 4, I get 4 in the middle. So my answers are negative 8 and also 4, but I have to go back and think about that. Is negative 8 okay to put here? Yes, because the only thing that would be bad is negative 2. Is negative 8 okay to put here? Yes, because the only bad thing would be 16. 4 goes the same way. You know, negative 2 and 16 are not either one of these answers, so these are both okay. So negative 8 and 2. Uh-oh, did I mess up? I don't see the answer. Oh, negative 8 and 4. Sorry. So that's letter A. Alright. So, let's see. Oh, is that the last one? Can't be. Make sure. Alright, that's it. Study for your test, please. You must do well. Good luck. Bye-bye.